Remember, my religion about recursion is that if you try to say, I recurse, and then I come back up, you're going to get muddled, right? So you should have a really clear pre and post condition. On an input with these properties, I'm going to get an output like this, right? And then I have some input, and I can trust my friends to give me the right answer, right? As long as, according to some definition, that input, their input smaller than my input, right? And their input meets the precondition, then they will give me something that meets the postcondition. Everybody remember this? And then if my input's so small that I can't, according to my definition, I can't make it smaller, then you have to solve it yourself, right? Everybody get that? So another thing you're going to have to be able to do to graduate from this course is solve recurrence relations, all right? So you should be able to say n is the size of our input, right? In this case, it could be a value or it could be a number of bits or whatever. And T of n says, how long does my program run on the worst case input of size n, right? And then A is the number of friends, the number of times I recurse, right? So here I'm recursing, I loop A times and I recurse, right? Then N over B is how big my friend's input is. If my input's of size n, then my friend's inputs are of all size n over b, right? And then into the C is how much work I personally do, right? Everybody get that? And everybody understand this currents relation, right? All right, so then how do you solve it? You don't need to know the proof. You need to say, how much work is the top level doing, right? This is into the 1, right? So C is 1. I'm doing into the 1 work at the top, right? How many base cases are there? You should memorize into the log A over log B, right? So A is 4, B is 2. Should be able to calculate that log 4 is 2 to the 2. So you divide, you get n squared, right? And now the 2, the base cases, dominates the work at the top, right? Because the 2 is bigger than the 1, right? Here we have C is 1, log A over log B is 2. This is bigger. So that's the running time, right? Everybody remember that? Versus, that's the same. Now, if I'm personally doing n squared work, right? Then, oh, this goes back to this one. Right now, I'm doing n squared work, so that dominates the number of base cases, right? So the total work is the work at the top, right? And the only funny case, well, is when the C and the log A over log B happen to be the exact same number, and then you just slip in an extra log n factor, right? So you should be able to review those and do those. Everybody good? Yeah? What? No. C, where is C? Oops, boy, we got too far ahead. I don't know where we are. C is the work I personally do. Here we are, right? So I'm personally doing into the C work. What? No, if I have an input of size n, right here I have an input of size n, so I'm doing into the C work. Yeah. Yeah, so normally in all the programs we've looked at, I'm either doing linear work, so C is 1, or I'm doing constant work, so C is 0. Right? Any questions about that? So here we can, right? What's merge sort? I cut the list in half. I sort the left. I sort the right. I merge the two together, right? So do I have a running time? No, I don't have the running time, but for merge sort, how many friends do I have? 2. And they're given inputs of size n/2, right? And then how much work do they do? Into the 1, right? They do linear work. All right, so C, this is C is 1. Log A over log B, they're the same, so you get 1. And that's why the time is order n with an extra log in there. Right? Does that make sense? We didn't do quick sort. Trees, right? We did quite a few trees. So whatever your problem is, I'm looking for, say, the number of nodes. I ask the left guy for the number of nodes, the right guy for the number of nodes, add their answers together, and add 1 because I'm counting my node in there. Right? Everybody go to that? And you should know that even if I have a lot of children, the running time is order the number of nodes. So what do? We do number of nodes. Right, that's all running time. And that's it. And we did it. Did you follow all that? Maybe not. Maybe not. You got any questions? Any topics you want to look at more? The knapsack. What? All right. That's what I was just getting this first. Yeah? Yeah, usually you're going to give if you give the best answer, it's theta. So n squared is big O of n to the cubed because it's bigger, and it's omega of n, right? But I wouldn't give you full marks for this anyway, right? I'm going to give you full marks for this, So really, we're asking for theta. Yeah. Yeah. What happened to my screen? More technical difficulties. Oh, there it's back. I don't know where it went. We lost our screen. So I'm not guaranteeing this, but I think we covered everything that's on the test, right? Except for what we're about to do. All right. That was added that wasn't done in the past, and we're going to do, and there are questions about knapsack problem on the test. Yeah. You know, yeah. If I'm not going to guarantee you're going to get 100%, but I'm going to say, if you understood all the words I said today, you're going to do pretty well, right? I mean, as I saw the topics, you know, what I did, I went through all the slides, and I grabbed the things that I thought were important, and I wrote down a question, right? And I'm pretty consistent in what I think is important. So when I put these slides in, I put the important things. And then when I talked, I said the important things, right? So more or less, you got it covered, right? And I don't think I have too many things that are tricky, right? There are a couple questions that maybe if everybody won't get, right? We don't want everybody to get perfect, right? All right, so I'm going to sit down and get rid of this, get rid of that, come over to this. I hate that thing. I don't know if you can see it. Sometimes you can, sometimes you can't. And we're going to recursion. We're coming over here to